So I'm recording the session as a FYI so that you all know. My name is Bill Zahner. I am a professor at San Diego State University, and I'm really excited to be here today to share using the Desmos Activity Builder to incorporate mathematical language routines in your remote learning. Just to make sure that people can hear me, Chandra, I can see you. Can you give me a thumbs up if you hear me? Good, okay. It's always helpful to know that actually I'm not just talking into the void. I'm sure that you all have had this experience before, so you can relate to this, this moment. We may get a visitor. For sure, my dog is here, and you never know if my 2-year-old will come barging in, so we shall see what happens. So I'm really excited to be here today to share an activity that I developed using the Desmos Activity Builder, and then to give lots of time for us to work together to think about how these activities might incorporate opportunities to develop language in remote learning modalities here. So that's the overarching goal of today's session. Before I go too far, I always forget to make sure I acknowledge all the folks who have contributed to this work. So listed on the top of this slide on slide 2 is all of the wonderful folks who have worked with me across the year, some of whom are actually here in the meeting with us, to develop some of the resources that I'm sharing today. So I want to acknowledge Ernesto, Heidi, Jessica, Josue, Brenda, Haley, Kevin, Alicia, Irania, Antonio, Linda, and April for all of their excellent help across the years here at State. As I said before, as a kind of form of shameless self-plug, if you're curious to learn about the research that we're doing, we have a short 3-minute video, which is on that link right there, the STEM for All 2020 videohall.com. So if you're curious to learn about what we're doing, you can follow that link probably after this session, or if the session gets boring, you can open a separate tab and put on headphones. Just kidding. One other logistical note is, thanks to Stephanie. That's nice that my jokes get laughed at. I never know. One other logistical note is that all of the slides for today are available on this Google Drive. So you can go to that folder and pick up the slides and some of the, one of the resources that I'm using today. All right, so with that, I think that students learn more when we talk less. That's one of my big philosophical ideas. So what I want to do is give you an opportunity to start off. So if you could go to student.desmos.com, enter this code, DHQFET, or if you have the slides open, you can click on the direct link. And you should be on the check-in screen, and on that screen you can move the point to show how you're feeling today. And if you want to add some explanation, you can move that point to a location and add an explanation. So I'll give you a couple minutes to check in there and make sure we're logged in. And while we're doing that, I'm going to randomly assign us to breakout rooms. So if you get stuck and you're not sure what to do, you can ask folks in your breakout room. So let me open up those breakout rooms. And we'll try out the breakout rooms and going to student.desmos.com and following that. Okay, looks like everyone was bumped back into the main meeting, so welcome back. Hope everyone is doing well. If you're curious to see kind of an overlay of how we're doing, this is a graph, and one really nice feature of Desmos is that we get to see where people are as a kind of holistic view. It looks like most of us are positive, which is really great. I'm happy to hear that. And we are tending from the energetic to the very tired. Looks like multiple Zoom meetings in a day is very wearing. I would certainly concur with that. So this is really great. This is just a demo of one example of what are called check-in screens, and I copied this check-in screen from the Desmos library of check-in screens. And at the end of today's session, if you want to ask some questions around the design of the materials that I built today, I'm going to leave lots of time to talk about that. So this is a good time to talk about our agenda. So the general agenda for today is going to be first just answering the question, what are these math language routines? Then I'm going to introduce the main task that we'll be doing today, which is called stacking cups. It's a task that probably many of you have seen, taken from the SBAC release performance tasks, the 8th grade release performance task. Then we will work on that task in breakout rooms using Desmos, and then reflect on the language development opportunities that are built into the task. We'll then experience 2 of the embedded math language routines that are inside the task. So there's math language routine number 3 called critique, correct, and clarify, and math language routine 1 called stronger and clearer. And then we'll reflect on the MLRs and the Desmos activity builder and answer the questions, how can we use this in our teaching? And for that part there, what I want to do today is leave a lot of time. So we've blocked off 2 hours. My plan is not to talk for 2 hours. That would be painful and mean to everybody. But instead to spend a lot of time working on these activities and then leave an ample amount of time at the end for folks who would like to stick around and ask questions and kind of look under the hood. So that's the agenda. I'm going to take a sip of coffee so I can pause and get my voice back. I told my students today that this is a great way to, some ways, check wait time. Always be drinking coffee. Okay, so what is a math language routine? This is not something that I developed independently. In fact, I didn't develop the math language routines at all, but instead this is referring to the work of a couple of different folks who are researchers and professional developers. And so Zwiers et al. Have a paper where they describe a math language routine as a structured but adaptable format for amplifying, assessing, and developing students' language. And the math language routines are built around 4 design principles, and those are 1, to support students engaging in sense-making. So doing mathematics in a way that makes sense rather than just plug and chug, if you will. Second, optimizing output, so creating opportunities for students to talk and creating the most opportunities or really excellent opportunities or opportunities for productive talk. Cultivating conversations, so creating space where students need to interact, either student to teacher or student to student. And the last one is maximizing what's called linguistic and cognitive meta-awareness. And that's a way of saying engaging in these principles to get students to think about what are good uses of language in this setting. So those are the design principles behind the math language routines. In the classroom-based research that we've been doing, we are working on redesigning high school math classrooms so that students engage in what we call productive and powerful discussions and building on the assets of linguistically diverse students. And in that work, we have found that these math language routines are extremely useful for getting students to talk to each other and for promoting whole class discussions. So discussions where students are coming up with ideas, reacting to each other's ideas, and so on. So as I mentioned, kind of giving full credit, the MLRs 1 through 8 are from Zwiers et al. And they had this great paper. There's a link there on this if you want to go read it. It's not that long. And then 9 and 10, which we added to this list from Zwiers, was from the work of Mark Driscoll and his colleagues up at EDC, who have a really great book on mathematical thinking and communication. So those are some of the resources that we've used. And if you would like access to more of the resources that we use, in the folder that we have here, there is a, it's not there yet. I will put a handout which has these MLRs and also has the design principles of our project and also has the a full set of resources or citations if you want to learn more. Okay. That's what a math language routine is. I realize there's some irony that I'm talking at you as I describe a math language routine, so I apologize for that. So there are 10 MLRs that we've described: stronger and clearer each time, collect and display, critique, correct, and clarify, information gap, co-crafted questions, 3 reads, compare and connect, discourse supports, and then a co-constructed word wall and acting it out. These are a list. They're not necessarily an exhaustive list, but these are the ones that we've used multiple times in our design work. For today, we're going to focus on 2 of these language routines. So the first one, which is called stronger and clearer each time, and the second routine called critique, correct, and clarify. And to give a kind of overarching framework of this, you might think of stronger and clearer each time as a sequence that we go through to develop language. So students might create a text, and then they have some kind of opportunity in the middle to reflect and review on what they've done right here. And then they go back and they revise that initial text. And this could be either a text in the sense of a verbal statement. It could be a written explanation. It could even be a written explanation with a diagram. You could, when I say create a text, I guess I'm using that word text in the most general sense I can think of. But the idea of stronger and clearer is that the first time you say something is likely not going to be the final time you say that. And that this process, thinking of language as something that you develop and refine across time, is one way that we can really develop students' language in mathematics and develop students' mathematics by having students use language. That's kind of the nice reciprocal relationship. The other MLR we'll be talking about today, the other math language routine, is called critique, correct, and clarify. I should add that I really want to add complement as another way of thinking about engaging with a text, right? But the students might interpret some given text or some given piece of information, and then the student's task is to make sense of that task, make sense of that text, and then to offer some comment or to offer some revisions or to offer some suggestions on how they might clarify or questions they might ask. And this is, again, getting to this idea of promoting student sense-making and also meta-linguistic awareness, right? Getting students to think about what are the features of a good explanation. How could I tell my colleague or my friend to do such a thing? So that's what we're going to do today. And I'm going to try to stop talking and let us do some more doing. So let's jump ahead and let me introduce you to our task today. So today we're going to be doing a released SBAC performance task called Stacking Cups. This is a task that was written for the 8th grade performance task. And it has 5 questions about one situation. This is maybe a familiar situation for those of you who have been around for a long time. I think I've seen this in multiple different variations, shopping carts, stacking cups, or other such structures. Where students are asked multiple questions about this stem. And there's the first 3 questions are traditional questions. So students are asked to solve for particular values and write an equation. And then in question 4, they're asked to interpret someone's reasoning. And then in question 5, there's a design challenge. So that's the overarching structure of that task. And the original task and the scoring guide, if you want to see that, you can use this link here. Probably again at another point, but I want to share that with you there. So what I want to do today is focus on that design challenge, but that doesn't make sense unless you've done 1 through 4. And that's where these 2 MLRs are going to be embedded. So in question number 5, in the design challenge, that's where we'll see that. Okay, so at this point, I'm going to launch us back into groups. And what I'd like you to do is to return to student.desmos.com. The code that you're going to enter, I'll post that again in a moment. And what I want you to do is to do problems 1 through 5 of this task. So we will open up the breakout rooms, and I will open up problems 1 through 5 from this task. Let me go do that first. And For those of you who know Desmos, I'm using the pacing in order to keep us all on task here. And at this point in Zoom, I'm going to open up our breakout rooms. And I will open all rooms, add a room, open all rooms. So you should be able to go to your breakout rooms and work on this task. And there's some of you who are unassigned. I'll start assigning you to new rooms. All right, welcome back, everybody. It's really great to see you all here. Looks like, just so you can see a little view of what it looks like on the other side, from the teacher view on this activity, I have anonymized the information, so if you want to see, there's your names. And here I can see where people are in the activity. So I was able to see that most of you were up on question 5 at the point when I had decided to close the breakout rooms. So now let's get to the heart of the matter, which is these math language routines. So if you notice that problem 5 was a design challenge where students were prompted to make a cup that meets certain constraints. And there are many possible answers. So students have to define the parts of the cup, for example, the bottom or the top, the base and the lip. And they have to explain their reasoning and how they know that their design meets the criteria that were set out in the problem. And this is where I saw a great opportunity for these two MLRs, stronger and clearer, and critique, correct, and clarify. So what we're going to do next is spend some time looking at 2 ways I designed this into the task, and then give you an opportunity to do that. So the next 2 slides, which you didn't see yet, are 11 and 12. Where the students are going to be given 2 made-up explanations for the design challenges from number 5. And the tasks that they're prompted with is what is good about these explanations, what is missing, and then how would you revise the work that you see here. And then on slide 13, the students are going to have an opportunity to reflect on what makes for a good explanation. So this is an example of the math language routine, critique, correct, and clarify, because the students are looking at a text and one that they've already thought about a little bit. They've thought about their explanation. Now they're going to see someone else's explanation. In this case, it's a made-up student's explanation that I created. And you'll see that one of them is correct, but not very well specified. One is well specified, but not very correct. And so the students have an opportunity to react to 2 different types of answers to this task. And then on slide 13, they have a chance to reflect upon the response that they see. Finally, on slide 14, this is where the stronger and clearer comes in. The students will go back and revise their explanation from their original answer to question 5. So on slide 14, what happens is that their response from slide 10 will be piped in. So it'll be copied from slide 10 over to slide 14. They'll see their original response. And now they have an opportunity to make it stronger and clearer, to revise what they've said before. So that's what's going to happen next. I thought I'd bring us all back to check in on that. And now I want to send us out to do that. But before I do so, does anyone have any questions? You can throw those questions into the chat window if you have one before I launch us off into group work. And I don't think I have the chat open. I don't see any questions coming in on the chat. I practice my wait time again, though. Have a cup of coffee. Yeah, the joke's only funny the first time, I know. Sorry about that. Okay, so with that, I'll send us back into the breakout rooms.
Carol has a question.
Oh, go ahead.
It's her question is, won't the cups be huge?
That's a great question, Carol. I think it actually kind of depends on the design features of the cups that you choose, but you could create an enormous cup that fits these criteria, which is kind of an interesting point. So you could have an absurdly large cup. That should be a great question for your group to think about. the different types of responses that are possible to this.
I thought I'd come up with an answer, but I realized after I came back that it was actually wrong because it was the height for each cup separately added together was 125, and that was a reasonably sized cup. So it's going to for 10 cups to add up to 125, unless, yeah.
Tough to meet that. Yeah, actually, so I'm glad you're saying that. You're anticipating precisely something coming up. So I'll put us into
sorry.
Groups. That's all right. I love it. Put us into breakout groups. This is a sign that great minds are thinking alike. So put us into breakout groups and give us an opportunity to work on the next few tasks. So I'll open up the breakout rooms. Okay, welcome back, everyone. The participants are coming back in. I think everyone's going to be dumped into this room in about 5 seconds. So here they all come. Okay. Welcome back, everybody. I am excited to have you back. I hope that that experience was productive working with neighbors and working with friends on this task. And to revisit, I think, the structure of this task and just to make sure that we all kind of see the design that was here. The way the task is designed, if we want to look at this view of the Desmos for a second, just as a reminder, questions 1, 2, 3 were really to kind of set up the task. Question 4 had one opportunity to think about someone else's reasoning. Question 5 polled the students to give an answer about a design task. And I think as many of you saw, that was actually a pretty non-trivial or rather non-trivial design task. And then to support student language production on question 5, I added these slides, so 11 and 12, which had the sample student responses, and the task or the challenge of critique, comment, or clarify. So that was slide 11 and slide 12. And then on slide 13, I asked the students to reflect on this question, which is kind of the meta-linguistic awareness. What makes for a good explanation, right? What should be included? And then what information would you want to include in your explanation for number 5? And so the goal here is to get students to engage in some of this reflection action, thinking about the quality of a good explanation. And then finally on question 14, students were able to then go back to their previous response and to revise it. And you'll notice that the old response was piped in, and then the students could revise their response as well. So that was the design that was behind this and some of the work. So let me take a few minutes just to offer some reflections, and then we'll take a look under the hood, and we'll leave lots of time for Q&A at the end. So my goal was to stop talking in about 10 minutes at the most, let you answer a couple of reflection questions, and then leave the rest of the time for Q&A. So on the reflection, I think one important thing to think about the structure of this task is that we solve this task, questions 1 through 5, and that's where we write this explanation. Then the students react to these sample explanations and reflect on the qualities of a good explanation. And then that primes students for the stronger and clearer, which is where they revise the explanation. So I'm designing this specifically for remote learning. And I would say that if we were doing this in a live classroom, I might do this quite differently, right? I might have students exchange their responses to question 5 and then offer critique and comment that way, and then exchange back. So this is a modification that was designed and kind of using the tools of Desmos to make that possible with the activity builder. So that's the kind of structure that I was using there. And I think that if you think about these math language routines and how they work together, I think that the stronger and clearer and the critique, comment, and clarify, they pair well together, right? They're kind of like a nice, what do you want to call it? Like a dessert or wine pairing kind of thing, right? Like these two are kind of mutually supportive and help each other out. When thinking about doing this in the format of remote learning, I think there's a little bit of planning that goes into how to do this. And so what I did in the design of this task is I used the pacing tools on the Desmos activity builder in order to restrict you to certain screens at certain times. And that was by design. I can feel a little heavy-handed, honestly, but it's a little bit like in live class, you hand out information to students, you give them a paper when you want them to look at it. And of course, if you give them a paper and you don't want students to look at it, and you've handed it out, you've kind of lost the attention, right? So there's kind of an analog there. So the two pauses that I put here, I inserted the first pause. I let you work on questions 1 through 5 and write that explanation. And then there was a pause here, right? If we had more time, I might actually have you do that block of reacting to sample explanations and reflecting as another kind of bracketed pause, right? So now I just want you to focus on the reasoning of others and think about the qualities of a good explanation. That might be also a good time for some whole class discussion, or if you have a synchronous Zoom meeting, that might be a really great thing to collect student responses and have a discussion about what makes for a good explanation. Or if you don't have a synchronous Zoom meeting, might be a good opportunity to collect student answers and then create a presentation or some kind of an artifact for that. And then the last piece is that opportunity to revise that explanation. So I see some real power here in the Desmos pacing as a tool for shaping how students experience this in their remote learning experience. And I should say, as I'm going along, if you have a question, particularly a pressing question, you can pop it into the thing. So I see one that came up that says, is there a reason the annotations to the cups didn't come up when we were to revise? Oh, that's interesting. That could be that it was an error. The annotations should be there, I think, on the revise. They were not there? Oh, I see, your previous annotations. Actually, that is an interesting question. That the previous annotations, I could have tried to pipe them in as well. And I chose not to do that, thinking that the students may want to start with a fresh image. But it's an interesting question. So you could actually design this so that they pipe in their previous annotations.
You have a couple more questions about whether you were thinking about this using this synchronously or asynchronously, like in relation to, for example, breakout rooms or to students responding, like for students who complete the task early versus later.
That's a great question. I think that one way that I could imagine doing this asynchronously, so today was kind of a synchronous moment, right? One way that you might do this asynchronously is to assign up to slide 10, up to question 5, one day, right? Let students understand the task and have some discussion about the components. And then 11, 12, and 13 on the next day. And so asynchronously, for example, you might broadcast a new message saying, okay, now we're going to revisit this problem. And then think about other people's reasoning on this. And then slide 14 could even be a third day or a final kind of chapter to that experience. That's a great question, though. So that would be one way to do this asynchronously, where you still, I guess you do have anchor points though, right? So like maybe everyone works on this on Monday to Tuesday, and then on Wednesday you move into the next part of the task, and then on Thursday or the next day, the next part of the task. So you don't have to be live, but it is still paced in some way. The pacing, the nice thing in Desmos is the pacing, you can leave it live or leave it there for, I think I've left it on overnight and it seems to stick. So, so the pacing stays paced. So if students go back to that activity, they can't jump around like you want to. I'll wrap up with a couple little pieces of what's behind the hood. I see some more questions coming here about would you have to type in, or does the program copy it for you? So I think I'll answer that one and then open it up for some more questions. So if we look under the hood, the way that this activity is designed is that the student's response from slide number 10 is piped into slide number 14. So it's copied automatically. So I did not do any quick copy and paste. And if you wrote a bad word on slide 10, it showed up on slide 14. Don't try that, or you can, I don't care. But so whatever you write on slide 10 shows up on slide 14. And the way that I did that was using what's called the computation layer. So I'm going to pop out of this activity and kind of show you behind the hood or under the hood. This is the activity in the activity builder mode. And if I go into the edit mode, then what I did is I actually programmed in some code to copy the student's response. So here on slide number 10, what the student types in shows up right here in what's called input number 7. And I know I'm going very fast here, but I just want to show you kind of a sample of this. And then if you have more questions, I'm happy to talk more, or also probably the folks at Desmos are much better explaining this, so I'll do my best. But what I did is I took the input from 7, and down here on 14, what I did is I then took the student's response, which is the content of input 7, and then this is where it says, here's what you said before. And this thing called answer is whatever they typed into input number 7. So this code that I used here is how I was able to take the student's previous response and allow them to revise that in the stronger and clearer mode. This is kind of an advanced feature of the Desmos activity builder called the Computation Layer. They're doing daily webinars if you want to learn more about how to use Computation Layer. But the really great news is that if you want to do this on your own, you can take this task that I've designed and basically just take those 2 slides and they'll work together. You can copy and move things around. As long as you don't rename the components, you can actually use that there. And the little code that you see there, the hashtags, yeah, those were there basically as an emphasis. I put those there purely because there was no way for me to change the font on the text. So it's kind of like the very old school, you know, kind of ASCII characters. I remember the way back in the early internet, the ASCII art. But that was a way to just show the students, this was your thinking. If I had control of the font, I would make that Comic Sans or something funny so the kids would get a kick out of it. But Desmos doesn't allow you to get creative because they want to be in control of the look. So that's a little bit of the under the hood, and I realized that I might have been just opening an iPhone for you, and you're thinking to yourself, I have no idea what he just said. If that's the case, that's okay. You can still use this activity by copying and moving it over. And if you're thinking to yourself, yeah, but how am I going to remember all that? Good news. If you go back to the very, very beginning, you can actually watch a little overview. So I have a video where I walk through what parts of this to use and how the different slides are related. And I see that Lisa has pasted in here the link to the activity so you can copy and edit it yourself. And that would allow you to edit this activity. Okay, so to wrap up, I'll just say that you can copy and use this activity as it is, assuming it fits your needs. I'm assuming not all of us are about teaching this lesson about adding cups. So you can also edit the activity and you can change the task and the prompts. As I said, there's some minor computation layer coding that's here. And you can see where that code is and edit it by clicking on the green sprockets if you're curious to look at that. In the worst case, if you break it, you can always just copy it again and then keep playing with it, or even send me an email. I'll be happy to answer any questions. And I would strongly recommend, Desmos is doing daily webinars now about the activity builder and also about Computation Layer. So if you're curious to learn more about the powers of these tools, and they're very powerful, it would be a great opportunity to join those webinars. And for that, I think it's at learn.desmos.com. So let me close with a final check-in. So going back to the activity. I'm going to open this up. And I will, you can see my pacing is still there. So give you an opportunity to answer one last question and check in with your group mates. And then I will bring back the group to the whole group and have kind of open Q&A. So maybe one last opportunity, check in with your group. You can say, it's great to meet you all, and answer the final reflection question there. Let's say that again. So welcome back, everybody. I apologize for the little technical hiccup there. Just want to recognize that I know some folks have to head out around 3:30, so I want to respect everyone's time for those who have to leave at the half hour. So my main goal for the remaining half hour is to stay on the line and do open question and answering and answer some questions for folks who are looking for resources. I do want to acknowledge that the San Diego Math Project is the sponsor of today's webinar. So thank you to Lisa Lamb, who is the I don't know, the boss of the, I don't know what the right word is, the director of the San Diego Math Project. Thanks, Lisa, for bringing us together and for sponsoring this. If you go to the sdmathproject.sdsu.edu, you'll see other webinars that are coming up and other opportunities for professional development. So thanks to all who came today. The main goal I have for the last half hour is to give opportunities. You can check in with your group or stay over here, but ask questions of, what questions do you have about using the activity builder? We can ask questions in the chat. I think maybe we'll leave it open as a whole group for a few minutes and field some questions in the chat. And then give us an opportunity to play around with the activity. In particular, Lisa put the link to the Desmos activity builder where you can copy and edit this activity. That's in the chat. Up a few more of these, so we can look at that. And one last resource I want to make sure I point us all to is that Desmos is doing webinars. So if you go to learn.desmos.com and click on the webinars link, they do daily webinars, both an introduction to the tool itself, Desmos Essentials, and then activity building for beginners. So if you've never used the activity builder, you can build your own activities here. And then advanced activity building, which is where you start to use the computation layer, which was the tool that I used to pipe students' responses from one screen to the next. So that's a resource there that if you're looking for other opportunities to learn there. So with that, I will transition to answering some of the questions that you had there. So Lisa, is there a way that you could help me see some of the questions? I see a few that are about, can the students share their screens to give each other input on their work, either synchronously or asynchronously, coming from Carol. That's a really interesting question. I think that the basic answer is if they're working in, say, a platform like Zoom, then you could, for example, have the students on the Desmos and then have them sharing their screens using the Zoom tool. So it'd be a combination of two tools. As far as I know, there is not a way to systematically have the students exchange information in Desmos that the teacher can control. Desmos does have built in some activities that allow students to interact with each other. One of them is called the polygraph, which if you've never done, it's like extremely awesome. But on the polygraph, I don't think the teacher can control who gets paired up or how they share. So as far as I know, that's not possible to, for example, have the students swap papers, which is, I guess, one of those great affordances of like paper and pencil, right? You can just say, group A and group B swap papers and so on. As far as I know, that's not available, but I am open to be corrected on that.
There's a question about whether you, there's a way you would recommend students show their written or drawn responses to each other.
So I think the basic way that might be the best is the teacher can collect the student responses using the snapshots tool on Desmos. So that's one way that the teacher can share. So it's kind of curating the student responses, and they could share the student responses that way. And the way that the snapshots work, there's a little way here to select and sequence student responses and add photos. And this is a really great way to, for example, if you're doing a synchronous class, to then highlight particular student work that you want to show off. For having the students to share the responses with each other, I don't have a specific recommendation for that in asynchronous learning. I'm curious if anyone out there, kind of crowdsourcing that question, if someone has an idea of how to get students to do that. I know that there's some logistical challenges that are faced. Of course, the teacher could be the one who does that, but it would be nice if that could happen automatically or more smoothly.
I've seen Desmos activities where when you're doing it synchronously that it'll say, here's what your classmates said. And so I don't know if that's available to code into an activity that they're doing asynchronously. But I would imagine that they could. And then we'd say that they need to be on Zoom in order to talk to one another, but they don't need to see each other's faces necessarily. We told our students, do this Desmos activity with a friend, like call them on the phone and talk about it as you do it. So I don't know, just ideas.
Sometimes the lower tech is much better than the higher tech, right? I completely agree. Yeah. And Bria, it's funny, I did look into, there's probably a way to do what you're describing. I tried with Computation Layer to try to program that where I could control. So what Bria's describing is that in Desmos, when you're doing a live class, you do see a stream of kind of what people are answering. There may be a way to grab that text and sequence it, but I haven't figured that out myself yet.
When you're in Desmos Builder, I've not tried it, but when you're in Desmos Builder, are you able to grab other activities that were already built and look at their code?
Yes. Okay. So in fact, that's how I've learned most of what I've learned about how to do the coding is you can grab other activities and then you can look at their code. And they also have a really nice documentation page, which takes a while to crack through, but once you figure it out, once you figure it out, it helps a little bit. So.
There's another question about managing breakout rooms while also looking at student responses on Desmos.
Yeah.
And another one about getting a language added in Spanish. I'll give you both, even though they're different.
So about the additional languages, I think that you can create activities in additional languages and you can translate activities. As far as I know, I don't know that they have a method to do the translations automatically. That would be a really nice thing to do. I know that folks have started creating activities in different languages. That's been in my own work. One of our interests actually has been creating more Spanish language Desmos activities or more bilingual activities, so having both languages side by side. If we start building up a collection of resources, this might be a great opportunity for us to kind of build some resources. As far as I know, I don't know that you can search their activities by language, but that would be interesting to find out. And then Diego is asking, how difficult was it to manage the Zoom breakout rooms while looking at student responses? It's kind of a challenge. Those of us who've done or tried to do synchronous learning, I don't know if we've done it, we've tried. The breakout rooms are really challenging because you don't have a good sense of the room. So one of the things I struggle with as a teacher is that in live class, I really like to listen in on multiple conversations and get the sense of the room and who's where. And I'm not finding that Zoom makes that easy to do. It makes it really great for me to actually, Zoom is a great name because I can be right there with one group, but then it's very hard to keep track of what's happening to the other 8 groups or 9 groups that are in the room. The nice thing with the teacher summary view, the one benefit, I guess, is that I can see where everybody is in the activity. So there is a nice piece here where pairing this with the Zoom breakout rooms, I can kind of see who's where on the activity. And right now I've anonymized everyone's names, but if I unclick this, I can actually see the folks who are here in the meeting. So with your students, if you have them logged in and using their actual names, this is a way to keep track of where people are during those breakout rooms. And I will say that using these pacing tools was really helpful. So this is the pacing guide here. And by using these pacing tools, I can manage some of what happens in the breakout rooms that way. I see Ashley offered an idea. If you're using Microsoft Teams, you can create a channel and have students post screenshots of their work. And then they can comment on each other's work. That sounds pretty awesome. So thank you, Ashley, for sharing that. I think it's a solution to those things. Carol, your next question showing up, who owns the rights to our work we create on Desmos? I have asked that to Desmos, and they are pretty cagey about answering that question. So for now, I'm assuming that anything I create on Desmos is going to become public domain or out of my control. That's an interesting challenge, and honestly, one that I have a little bit of a qualm with, thinking about the bigger picture. But I think right now, everyone's on Google Classroom, everyone's on these different platforms. But there's some big questions about ownership and who gets this information. I know Desmos is now selling or adapting curriculum. So it's an interesting thing if our activities are entered into that. In this case, I should say that the activity I used was not mine in the first place. This is the stacking cups was a SBAC task. So I want to make sure you don't at all credit me for that task or the format for that task. Or blame me, I should say, either one. Oh, that's funny. Just a question, how did I annotate my Google Slides with pen? That's a Zoom feature. The Zoom has an annotation tool, and so that allows us to put things into or to annotate over the slides that are on the Zoom call. Are there additional questions, or do folks want to play around with Desmos while I'm here? And I'm happy to just kind of be the tech support on the line, or also I'm happy to give you 20 minutes of your life back. 23, that's like a 22, sorry. Time is ticking. Did I miss any questions? Lisa, can you say more about your thinking there?
Actually, not really. Just in the last couple of days, we've had suggestions of folks using Google Jamboard and or Padlet as a way to have lots of folks responding to something similar. What I'm not sure is whether or not they can upload screenshots and then respond to it. So I'm not sure whether that would be a good option or not. similarly, I'm not sure if Padlet would work either, but yeah, and then lots of people have mentioned that Flipgrid that I'm seeing listed in the chat here has added some recent functionality that's made it very usable. So these are all, of course, there's so many different options and so many things to explore. It can be overwhelming. So I hesitate to send you too many places, especially because I'm not expert at them, but I know people have been pretty excited about both Flipgrid and Jamboard.
That's great.
We're delighted that all of you took the time to come today. So and we will be here until 4, and you're welcome to play around on Desmos and then come back and forth. So thanks so much for coming today.
Yeah, and Carol, I saw your question about is there an instruction booklet, and I think that at least using the I'm not sure if you mean on the Desmos platform or if you mean on the in general for the MLRs. But if you're thinking about the Desmos platform, they do have a website. I think it's learn.desmos.com that has really nice kind of sequenced lessons there, or sequenced introductions to their various platforms and tools. All right, and we'll stick around if you want to play around with this and work on it. I'll just be here hanging out, and maybe if we're lucky, my child or my pet will come into the room. We'll have like a show and tell at the end. Actually, by the way, if you ever have to do a live Zoom class, I strongly recommend this, that you wear a silly hat, and it really surprises your students when they come back from breakout rooms if you're wearing a funny hat. So just we got to do what we can to enjoy life these days. I thought I was kind of going off the, going crazy, and someone was like, "That was the best thing you did our class this semester." Okay, so I did something right.
Thank you, William, for your time. You've given us a lot to think about.
You're welcome.
And thank you, Lisa, for making sure that I got wind of this. So everybody have a wonderful time and play, and don't work too hard and get too exhausted. We can all do this.
Great to see you.
Bye-bye. Thank you. Bye.
Hope you're well. Take care.
Bill, will the recording of this be available?
I believe so. Lisa, you're going to post the recording of this?
I'm muted. Sorry. Yeah, it's on SD Math Project, as in San Diego Math Project, .stsu.edu. Just reposting in the chat.
Great.
Thank you.
And so it may take a day to get there because it just depends on, Zoom's been quite fast recently, but it just depends on how quick Zoom gets the recording up.
I was going to say thank you for modeling the breakout rooms and how effective that can be. Makes me want to require my students to come to a Zoom, but we're not allowed to. So I plan to have a Zoom later this week, and I will advertise that they can go into breakout rooms. But I think the fear is that it's like leaving a student in a room without an adult. And that's what they've asked us is can you make sure that you are in the room? Don't leave a don't leave a room open and then exit it and leave kids in there. That would be my fear, is that you can't hear everything that's going on. But I think about the classroom, when you're across the room, somebody can whisper something mean or negative to a group mate, and there's nothing you can do about that unless a student reports. So I don't know. I was just trying to think through that.
Yeah, that's an interesting challenge, and that's what I was kind of describing, that when I'm using the breakout rooms in my synchronous class right now, it's really hard to know what's happening in all the rooms. So I see both sides of this, right? But I think the students really benefit from talking to each other.
Yeah.
Mm-hmm.
And
that's why I thought it'd be cool to let them choose and be with their friends.
Yeah, that's a good idea, actually. That might take care of some of that problem.
Yeah.
There's also an easy out. I mean, you can leave the breakout room anytime, and I think that's all participants can leave. So it's a easier escape than it would be if you were in a classroom, I think, in a small group having a kind of a terrible time. So
that's a good point too.
Yeah.
And I mean, part of it is just like, if you tell them, hey, I can review, if they let us record it, but there's, what is it, FERPA or whatever the law is that doesn't allow us to record students. That's the hard part, is like, if we could record, then it's this accountability piece that says like, hey, anything you say and do can be reviewed on recording. But without that, it's like, oh shoot, I'm putting a bunch of 15-year-olds in a room together. Who knows what they might say or do.
Yeah. It's a hard situation.
Yeah, but it's really cool.
To answer your question,
their parents don't have to be monitoring them, but somehow you are supposed to be monitoring them.
Yes.
There's a lot of ironies in this world.
Oh,
I
so
also
many.
think that a lot of parents perhaps might start respecting teachers now that they've been at home with their children. And I love children, and children generally listen to me. So if I sound cynical, I'd hate to think somebody who can't manage kids how they feel. But my point is that parents don't realize, most people don't realize how hard it is to engage children and get them to do what you ask them to do, especially if that is not a pattern that was already set up before they came to our classrooms.